Hello, everyone, and welcome to our webinar today. This is the fifth installment of the John Muir Project's webinar series, Understanding the Science, a webinar series that does a deep dive into the newest and most relevant science on topics such as wildfire, ecology, biology, and a bunch more. We do this to get this information out to the public and to reporters and also members of Congress in a universally digestible way, as we understand that some of these topics are at a high level of understanding, and we try to bring the nuance down to a digestible level. The webinar today is going to be split up into multiple parts, with each presenter giving a speech on their topic, and then we will be doing a full panel Q&A after their presentations. We ask that you submit all your questions to the Q&A discussion board. And just as an FYI, today's webinar will be recorded and distributed with our follow-up materials. And with that, if at any point your questions that are submitted do not get answered in our live discussion, they will be answered in a written format and sent out. And that's one of the perks of registering for today's webinar. Thank you to everyone who registered. We had a wonderful registration count for today and a really awesome attendance. Before we begin today's webinar, at the start, you should have received 4 polling questions. One is pertaining to your scientific background and experience. The second is your personal interaction with wildfires. And the third and fourth are about how you heard about our series and what outlet kind of made you decide to register. All of this information is kept private. It's not shared with anyone. And we do this in order for record keeping and also to make sure that we can tailor our discussions in keeping people's past experiences and past potential traumas in a respectful manner for discussion. If at any point during today's webinar, you're feeling triggered by a discussion or something is making you uncomfortable, please feel free to message me as the host, and I will do my best to accommodate all of your requests. With all that out of the way, please join me in welcoming today's panelists. On this episode of Exposing Wildfire Information, were 30% of Southern Sierra forests lost in the past decade, which is our 5th episode of Understanding the Science. I am joined today with Dr. Chad Hanson, the Principal Forest and Fire Ecologist of the John Muir Project, and Bryant Baker, the Conservation Director and Researcher for Los Padres ForestWatch. Excuse me, Bryant. Our speakers are going to be offering a new analysis that debunks this misinformation and exposes the truth behind what's really happening in our forests. Our speakers are also going to explain how this is impacting not only our forests, the scientific process, but also subsequent forest policy issues. So welcome, Dr. Hanson and Mr. Baker. We're so excited to have you with us today. And with that, please help us understand the science. Take it away.
Great. Thank you, Marie Claire. And I just want to make sure everyone can see my screen. Can everyone see the PowerPoint? Great. I see Dr. Hanson nodding. Right. My name is Bryant Baker. I'm the Director of Conservation and Research at Los Padres ForestWatch. We're a Santa Barbara, California-based nonprofit that works on a lot of land management issues along the central coast of California, including wildfire and forest management issues. I myself do a lot of research work, a lot of it with Dr. Hanson, actually, and several other colleagues from other organizations. And, a lot of my work focuses on trying to analyze data surrounding wildfire in both forests in California and across the Western United States, as well as shrubland ecosystems, mainly in California. And I do a lot of GIS work, so you're going to see a lot of my some of the maps that I've made about this topic specifically. And what we're going to be really focusing on today is this one single paper that just came out a couple of months ago. This one, called "Mega Disturbances Cause Rapid Decline of Mature Conifer Forest Habitat in California." This is by Steele et al. It was published in late October in the journal Ecological Applications. And this is actually sort of still a preprint copy. So you'll see, I'm going to show a map from their paper, and you'll see like a watermark that says it's an accepted article. So it may change slightly because of proofreading, but they did make this paper available already, and they made a lot of their data available. And so I'm actually going to be using a lot of their own data to sort of show some of the issues with their methodology and analysis. Now, this paper came out in late October and was pretty quickly picked up by several large news outlets like the Los Angeles Times, for example, that, the way they sort of reported on this paper was saying that nearly a third of the forest in the southern Sierra Nevada were killed by drought and wildfire in the last decade, or that they were lost by drought and wildfire in the last decade. And this is not actually exactly what the paper says. So I'm going to talk about how there are problems with the methodology in the paper, but the paper itself is actually one of their big findings was they say that between 2011 and 2020, about 30% of conifer forest, that was conifer forest in 2011, by 2020, 30% of that had transitioned to non-forest. They didn't use the words killed, or they didn't say forest loss, but that's kind of how the media really latched on to this and reported on it. I mean, the Sacramento Bee, California tree carnage, talk about hyperbolic media reporting on wildfire and forest issues, which we've become accustomed to over the last several years. So it's important to understand a couple of basics about this paper. So one, again, they looked at 2011 to 2020. That's their study period, and their study area is the southern Sierra Nevada. And I'll show you a map here in a second that will kind of show what area they were really looking at. But you really need to understand how they define conifer forest. So there are three main things here. One, it has to be dominated by coniferous tree species, right? Your pines, firs, Douglas firs, things like that. And the other sort of key component is that it needs to be at least 5 meters in height. So if you were to look at the average canopy height, that needs to be 5 meters. Okay, and then the last thing, and this is the most important aspect of all of this, and this is going to be the metric that we really focus on for the rest of today, sorry about that, is that it has to have at least 25% canopy cover. Everything else that doesn't meet these criteria, whether it's like oak woodland at lower elevations in the Sierra Nevada foothills, or it's like really rocky areas that just don't have a lot of tree cover. All of that is going to be considered non-forest, okay? And they basically delineated all of the conifer forest as of 2011, and then they looked over time at changes. They used satellite imagery, mainly Landsat imagery and some other data to basically look for, they were trying to detect changes in canopy cover. That's the sort of the main thing. And then by 2020, they would say, okay, this percentage of what was conifer forest in 2011 is no longer conifer forest. It's now something that they call non-forest in 2020. Okay, so canopy cover, just as a quick definition of how this is going to work. It's really actually quite simple. It's basically the proportion of the forest floor covered by the vertical projection of the tree crown. So this is just an example, and I think this is actually a pretty good way of envisioning it. So imagine that you have a 30 meter by 30 meter area, and we're looking down on the canopies, on the tree crowns, okay? So we're in the air and we're looking down, right? Basically, if we took the area of these canopies and then divided them by the area of this this box here, this 30 by 30 meter pixel. So my dog is coughing. Hopefully you guys can't hear that. You okay? Okay. So sorry about that. So if you took all the tree crowns, tree canopies, and took the area of those, and then divided it by this area, multiplied it by 100, you get percent canopy cover. Now it's measured a little bit differently on the ground, but this is just a way to sort of visualize it. So hopefully that makes sense. You're gonna nod your head on the other side of the screen. I'm gonna assume you're nodding your head and say, yes, Bryant, that does make sense, because it's important to understand that as we go forward. Okay, now I also want to give you an example of sort of the first issue that we come across here. This is before we even look at any of the data that Steele et al. Provide. Let's talk about that 25% canopy cover threshold. This is not what you typically see in the literature when you're trying to distinguish between forest and non-forest. Usually the number is 10%. That is, has been generally the standard minimum threshold of canopy cover for classifying forest or non-forest. They went with 25% canopy cover. And I just want to show you an example area. This is from the Los Padres National Forest. This is my neck of the woods. This is in the Chumash Wilderness on Mount Pinos. And this area has never been logged. It has very little fire history in the last many decades, but it is naturally, because of soil conditions and climate, it's naturally a very open Jeffrey pine forest. These are mostly Jeffrey pines, a little bit of ponderosa in here as well. If you were standing here in this area, I don't think anyone would stand here and say, I'm not in a forest right now. But it has about 17% canopy cover, this area, and would therefore not be classified as forest according to Steele et al.'s definitions. Okay, this is important to remember this. So kind of just think about this picture later on. So again, this is their study area. It's the southern Sierra Nevada. To give you some maybe idea of what you're looking at here, like this is Yosemite National Park in this area. That's the Rimfire. This is the Creek Fire from a couple of years ago. This is the Rough Fire from 2015. You can kind of see this smaller map here. We're looking at about the southern half of the Sierra Nevada mountain range here. And I'm going to show you some examples from various places within this study area of how their methodology has some issues. Okay, so the first one we're gonna start with is the Donnell Fire up here. This is in the northernmost part of their study area. This is a fire that burned in 2018. So this is how a lot of the rest of my presentation is going to go. You're going to see something that looks very similar to this. Okay, so we're in the Stanislaus National Forest after the Donnell Fire. We're looking at 2020 aerial imagery. Okay, so this is really high resolution, high quality aerial imagery that's collected every 2 years across the country. And this is just one area that you can see. This is the Donnell Fire perimeter. We're over in this little area. And you can see the tree canopies, right? So again, I'm just going to assume you're nodding along and you understand what you're looking at. If you've looked at Google Maps before and you've had the satellite view turned on, you should be sort of familiar with, looking at this. I look at this all day long, and I forget that people aren't as used to looking at these types of images. So I just want to make sure that people feel comfortable, looking at this and understanding what they're seeing. But what you're seeing is a lot of forest. You can really see it all throughout here. This is post-fire. So, right, this is 2 years after the fire. You can see a couple of patches where you can still see some sort of, it almost looks like blackened ground. It's mostly because you have a lot of dead trees there. Those are snags, blackened snags. So these are little high severity patches, but most of this area burned at low to moderate severity, mostly low severity. Okay. The black pixels that you see, those are, that's one of the data sets that Steele et al. Provided along with their paper. This is what they found to be non-forest in 2011. So these black pixels, they did not meet the criteria for conifer forest in 2011. So we're just going to sort of not worry about those. We're not going to consider that here. Okay, now what I'm about to do is I'm going to turn on their data set for canopy cover from 2020, okay? And what you're going to see is everything that is covered by this sort of transparent purple color, that has less than 25% canopy cover according to their data set, and would therefore not be considered conifer forest. Or another way of thinking about it is everywhere where you see purple, they're saying transitioned to non-forest by 2020, between 2011 and 2020. Okay, so we turn that on, right? And I don't know what your faces look like, but you may be like, oh, wow, that's way more than I expected. And that's exactly my reaction. And it was my reaction over and over and over again as I looked through the data and I started looking at areas, especially within areas that had burned. This is a major issue. And this is not a small example from one area. This is sort of indicative and representative of a much larger and more widespread problem with their data set, where basically they're saying all of this area, with the exception of a couple little patches, transitioned to non-forest because of the Donnell Fire. In reality, most of this area should still be classified as forest, right? I mean, I could see this, some of these little patches here, being purple, but for the most part, this is just astoundingly incorrect. Okay. And then I want you to think about, I want to go back to this photo real quick. Remember, this is 17% canopy cover. Okay. So this would not qualify as forest according to their metrics. Okay. Now, I want you to look at the exact same. So we're looking at satellite imagery now, but we're at the same sort of scale. So we're about the same distance away from the trees, what we're looking at here, as the photos of the Donnell Fire that I just showed you. Okay. So this is, again, on Mount Pinos, and this is going to make sense here in a second. This is in the Los Padres National Forest. This is where I took that photo. So again, this photo, I was standing right here and I was looking this way. So this is about the field of view of that photo. Okay. I want you to look at how open this looks like, from above. Okay. So we're looking down on the tree canopies and you can see this is really open. Now, this I would consider forest. I think anybody in their right mind would walk through here and say, yeah, this is definitely a Jeffrey pine forest. And you can see it's really open. Now, if we go back to the Donnell Fire, you can see it is much denser, much more canopy covered, right? And they're saying that it is not forest. Okay. So I hope that all makes sense. I've been thinking about this a lot lately, and I just, it's easy for me to visualize it and understand it, but I'm hoping that you all understand it. And we can talk about this more in the Q&A. Now I'm going to show you some more examples. We're not done with examples because there are a lot of them. And I'm just giving you a small snippet of all this. And we're going to go to the Ferguson fire. This burned in 2018 as well, just south of the Rimfire area, which is a pretty well-known area. This is kind of south and west of Yosemite National Park. So again, sort of same thing, right? We're looking at 2020 aerial imagery. We're looking down on the forest, and you can see this area burned a lot more. I think there's a little bit more moderate severity fire in this area. Not a whole lot of high severity fire. There's definitely some patches down here, maybe right in there. But most of this is low to moderate severity again. And once again, we see the Steele et al. Data from 2020 showing this as, because it is less than 25% canopy cover, non-forest. Now, one of the things we're trying to actually quantify is what is the actual canopy cover here? Because what we're fairly confident about is that most of these areas are actually above 25% canopy cover. So there is a problem, not just with the fact that they chose 25% as that minimum threshold, but what we're seeing, and a lot of, if you were to look at the actual values of a lot of these pixels, a lot is 0%, which is really bizarre and doesn't make any sense when you look at the canopy cover. If you just were to look at aerial imagery, we're actually trying to quantify, how accurate this really is, and what we're finding is it's not very accurate in a lot of these places. Okay, I'm gonna go down south now. This is sort of the southernmost large-ish fire from their study area. This is the Cedar Fire from 2016. And I'm going to do something a little different here. I want to show you, this is the 2016 image. Okay, so I want you to just look at all the forest here. Basically, there's very few of those black pixels. So all of this was classified as conifer forest in 2011. Okay, there's definitely some tree mortality happening because of the drought and the bark beetles here. But for the most part, you've got intact forest here. And this is what it looked like after the Cedar Fire came through. And everything within this red perimeter, red line perimeter here, that's all part of the burn area. Outside of it, over here and over here, that's all outside of the fire. Okay, so you can see, I mean, there's not a whole lot of change. This was a really low severity area, just not a lot of tree mortality from the fire itself. I would expect that most of this area should be classified as forest as of 2020, because again, we're looking at 2020 aerial imagery here. But once again, we look at the Steele et al. Data, and there are these huge patches that are being classified as non-forest, sort of inexplicably. It just doesn't make much sense. Now, I want to show you the fire severity data just to drive this point home. This is from the Monitoring Trends in Burn Severity data set, which is in part prepared by the Forest Service. This is a really a pretty robust database for fire severity. It's one we use a lot in research. And what you're seeing here is the green and the blue, that's all either unburned or really low severity fire. So less than 25% tree mortality is what you would expect in those areas. The yellow is moderate severity, and then the red is high severity. Red, usually in this data set, it means greater than 75% tree mortality. So again, you can see these areas that burned at mostly low, moderate severity. We look at the fire severity data, you can really see that in those data. But when we actually overlay the Steele et al. Canopy covered data, it's not adding up. We're seeing that the low severity areas are being classified as having less than 25% canopy cover and therefore have transitioned to non-forest. So what Steele et al. Are essentially saying, and they don't say this in their paper, what they talk about in their paper is they're concerned about high severity fire causing transitions from forest to non-forest. But what their data are actually showing is that even in the low severity fires, they're saying forest is transitioning to non-forest, even though they say low severity fire is what needs to be occurring across these areas. So it's not adding up. It's not really making sense. Their data seem to have some fundamental errors, and it has to do with their methodology, which is a relatively new method that's only, this is basically, I think, maybe the second or third paper that has even used this methodology, and it clearly hasn't been field validated enough. Okay, I want to go to a different area. This is not a burn area. This is actually an area that was mostly affected by drought and bark beetles. And they actually talk about this area in their paper specifically. So we're going to kind of zoom in. It's between the creek fire and the rough fire perimeters. We're going to zoom in on this area. Again, no fire came through here within their study period. So you can see there's definitely been some bark beetle activity. This is 2020 aerial imagery. By now, all the trees that had died, mostly between like 2012 and 2016, those have gray canopies now. The trees are still there. They're dead and they're kind of harder to see. But again, you still have intact forest. There's no question that this is still conifer forest. But once again, we turn on the Steele et al. Data and we see that they are classifying a lot of this as having less than 25% canopy cover, and therefore it has transitioned to non-forest according to them. And that's just not making any sense when you're actually looking at this aerial imagery. Okay, now I only have a couple more examples to show you. One is from the Rimfire. So we're going to go up to the 2013 Rimfire. This has been a really well-studied fire in a lot of different ways. I know a lot of Dr. Hanson's work has been in the Rimfire. And I want to point out something really interesting that I just came across actually yesterday in this area. This is really strange. So this is 2020 aerial imagery. So we're after the Rimfire, right? Again, we have those black pixels showing areas that were classified as non-forest before the fire, in 2011. So before the 2013 Rimfire. Okay. Now we turn on the Steele et al. Canopy cover data, and we see that there's this huge patch being classified as non-forest. It's because it has less than 25% canopy cover. Okay. So look at that again. If you're used to looking at this type of imagery, it would jump out at you immediately that there's a commercial thinning operation that has been going on here. It's very, very clear to see. You can see a bunch of landings. This is where this is where logs are decked. This is where a lot of like burn piles would take place. So major commercial thinning operation going on here. Okay. So Steele et al. Try to account for logging, timber harvest, whether it's from commercial thinning or from clear cutting. They try to account for that because what they didn't want to do is say, X number of acres transition from forest to non-forest because of wildfire and drought and bark beetles, but not consider that some of that acreage might have been transitioning because of clear cutting or some other type of logging, right? so they actually have this management data set that is about timber harvest that they also provided. And this data set actually comes from a different paper, and it only covers 2012 to 2019. So it doesn't even cover their full study period. So it's missing 2 years of data. So anywhere where you see red, they're saying if canopy cover dipped below 25%, or let's say that, the canopy height is no longer 5 meters. If it transitioned to non-forest, but it's within these red areas, then we know it's because of logging. It's not because of drought or bark beetles or fire. But when I look at the Forest Service's data, what I'm seeing, this outline, this is actually from a project, this commercial thinning operation. It's a huge commercial thinning project called the 2 Mile Ecological Restoration Project. This is in the Stanislaus National Forest as well. And they had already been doing a lot of work. This is 2020 imagery, but they had been doing work since I think like 2017. They had been doing a lot of this, and it was causing changes in canopy cover. And again, the Steele et al. Methodology picks this up as transitioning to non-forest because it is dipping below 25% canopy cover. Again, whether it's actually truly less than 25% canopy cover is sort of another question that we're trying to get at as well. But what I'm trying to get at here is they're saying all of this area that transitioned to non-forest, it's not going to be classified as transitioning to non-forest because of logging. It will be grouped in with fire, bark beetle, drought. And in this case, it will be grouped in with fire specifically because it's within the Rimfire area. So they're essentially saying the Rimfire caused this change in canopy cover, when in reality, it was actually this intensive commercial thinning operation that the Forest Service did. What I find fascinating about this is that a lot of this paper by Steele et al., their recommendations based on their findings is that we do a lot more commercial thinning, a lot more logging to try to reduce the incidence of high severity fire. And there, of course, we have a lot of thoughts about that, and we can talk about that more later. But what they're saying is we need to be doing more of this so that we can prevent fire from causing transitions to non-forest. Yet their own data are saying that very activity is also causing a transition to non-forest. It just isn't making any sense. And I know that may all be a little convoluted, and we can, I can certainly talk more about this in the Q&A session, but it's just really, really bizarre. There are, of course, other areas out here that are being misclassified as non-forest as well. So there's just a big mess going on here, especially. And this is not just on national forest land. They also were looking at private lands as well. And I'm seeing lots of issues from clear cutting. So if we look at this is a private inholding within the Stanislaus National Forest. You can see there's some older plantations here, some old clear cuts. And if we look, this is 2016. Okay, a lot of forests. Be looking right here. Now we're going to go to 2018, huge clear cut operation, right? Over here, and then especially right here. Notice that it's not in red. So they're not picking it up in their management database, even though it happened between 2016 and 2018. It's well within their 2012 to 2019 timber harvest data set. It should be included in that data, but it's not. And so their method here this time correctly identifies it as being transitioning to non-forest. This is a clear cut. There's no doubt about it. It's mostly going to 0% canopy cover, and their data set shows that. But once again, it's not going to be attributed to logging. It's going to be attributed to, in this case, because it's outside of a fire perimeter, it's going to be attributed to drought or bark beetles. And this is not a one-off event here. This happens all throughout this, mainly the northern part of their study area where there's a lot of clear-cut logging. They miss a lot of these clear cuts in their management data set, but they show them as having transitioned to non-forest. So hopefully that all makes sense. The point to all of this is that there's something fundamentally flawed about their methodology and the data sets that it produces. It is both underestimating canopy cover and therefore overestimating transitions of forest to non-forest between 2011 and 2020. Now, I'm going to hand it over to Dr. Hanson, who's actually going to talk about what do we actually mean when we say what do they when we look at an area that transitioned to non-forest because of high severity fire, what does that actually mean? Is it becoming non-forested? Is the forest being killed? Is it deforestation? What is actually happening there after the fire? So I'm going to hand it over to Dr. Hanson, but do definitely put your questions in the chat or in the question and answer if you have questions about my presentation specifically. Thank you.
Thank you very much. Really, very, very illuminating. All right, so I'm going to share my screen, and hopefully everyone will be able to see my presentation. Sometimes there's a little bit of a delay. Can people see my screen? Give me a thumbs up if you can. Yeah, okay. Good deal. So I'll be brief because I know folks probably want to ask questions. But basically, I'm going to focus on the areas that really did burn at high intensity, where 100% of the trees were killed, even the higher end of high intensity in these fires that occurred from 2011 through 2020, and show you what these areas really look like on the ground. So a little bit of background. The Steele et al. Paper used 25% canopy cover as a dividing line between forest and non-forest, and they cited a particular paper to justify that. Well, we read that paper, and that paper doesn't say that, doesn't say anything remotely like that. So that 25% just came out of the blue. In ecological sciences, the threshold that has been used by agencies, by universities, by hundreds of scientists for generations is 10%, not 25%. And it's important to realize what that 10% really means. It's not 10% canopy cover at any given point in time. It's 10% canopy cover or greater in the forest's mature state. So when the trees get mature, if the area can't produce at least 10% canopy cover, then it's typically classified as woodland or savanna or some other chaparral, some other vegetation type. In other words, if it's a mature forest that has 40% canopy cover, for example, and it burns at high intensity, and it's brought down to 0% canopy cover, ecologically, that is not considered non-forest if the forest is regenerating after the fire. That's the key point. So I'm going to talk about that. And just for background, if people want to do a deeper dive on this, the book I wrote last year, Smokescreen: Debunking Wildfire Myths to Save Our Forests and Our Climate, I go into a lot of detail on this issue of post-fire succession and natural conifer regeneration and some of the myths out there about that. All right, so as Bryant mentioned, Steele et al. Said 30% of conifer forest basically was lost, transitioned to non-forest over the past decade due to high-intensity natural disturbances, mostly high-intensity fire. So let's look at the areas that really did burn at high intensity. Now, I want to show you this little graphic. This is from the Steele et al. Paper. And if you look at that upper right image, they show an area at 10 years after high-intensity fire, and they say, well, it's shrubs, but it's not conifer, essentially type converted to non-conifer forest. That's the narrative that you hear from these folks, and these are Forest Service scientists who are funded by the Forest Service, that if you have high intensity fire, is type converted and it won't regenerate typically. So first off, I want to mention, ecologically speaking, it is a very, very well settled issue among scientists globally now that if you have a high intensity fire patch, that is not considered non-forest. That is absolutely considered to be a forest type, and actually a very highly important and biodiverse forest type that we call complex early sterile forest. And the only way we would call that something other than a forest type is if it's not regenerating with conifers following the natural disturbance process. And not just in the first year, sometimes it takes several years, it's natural succession. But it needs to regenerate. But as long as it's doing that, it's certainly considered complex early sterile forest. Okay, so this is me and Dr. James Hanson, eminent climate scientist, in a high-intensity fire patch in the Rimfire. And this is, of course, one of the areas that Steele et al. Say transitions to non-forest. Now, in this case, unlike the examples that Bryant showed, it really did burn at high intensity here. You can see that's 100% tree mortality. This is a large high intensity fire patch. And Dr. Hanson and I, the other Dr. Hanson and I, are standing in this area at 8 years post-fire. This was last year. And this is all natural post-fire regeneration. This wasn't planted. And you can see that it's well over the tops of our heads. This is absolutely forest. It is regenerating vigorously, and this is the typical pattern that we see in these high-intensity fire patches. This is also another large high-intensity fire patch in the Rimfire at 8 years post-fire. Once again, this is all natural regeneration, and you can see you have hundreds and hundreds of rapidly growing conifer seedlings and saplings per acre, many of them already 10 plus feet tall, 10 or 11 feet tall. And that picture was from Bryant, by the way, this one here. This is another area. This is another area in the Rimfire, high intensity fire patch. I took this photo at 8 years post-fire. And this area was in the center of one of the largest high intensity fire patches in the Rimfire. So this is deep, deep in the interior. This is more than 300 meters away from the nearest live surviving tree. And look at all that regeneration. These conifer seedlings are already 12 feet tall when I took this picture, and that was last year. And so this is regenerating very, very rapidly, very vigorously. And once again, like the other pictures, this is all classified as non-forest by Steele et al. The narrative that they're presenting to the media and to politicians is that high-intensity natural disturbances from high-intensity fire patches and also from drought and beetles are converting these forests to shrub habitat or to grasslands or bare ground, but converting it to non-conifer forest, that's not regenerating. And that is absolutely incorrect in the vast majority of cases. Another example, this is just 7 years post-fire in the Rimfire. This is another picture from Bryant. In a high-intensity fire patch, this is all natural regeneration. And look at all those seedlings and saplings you see in the foreground, fir, white fir mostly regeneration, and then ponderosa pine and some sugar pine taller in the background there. This is also Rimfire, 7 years post-fire after high-intensity fire. You have about 500 saplings per acre here, natural regeneration. This is a large high-intensity fire patch, long ways from the nearest live surviving trees. And these trees at 7 years post-fire were already over 8 feet tall. Right now, many of them are over 12 or 13 feet tall and already 4 or even in some cases 5 inches in diameter. And at chest height, this is what we're seeing in most of these high intensity fire patches. Once you get 7, 8, 9 years post-fire, it doesn't all come in at 1 or 2 years post-fire. Sometimes you don't have much coming in until 3 or 4 years post-fire, or even 5 or 6. But then it comes in really fast and grows really quickly. So point is, contrary to what Steele et al. Are telling the public and the press and policymakers, that this was converted to non-forest, that this was lost in the terminology of the LA Times, unfortunately. What we see, in fact, is that this was an area that did burn at high intensity, unlike most of their areas where they misclassified these low intensity areas as converted to non-forest. This area really was high intensity, but again, like all the others, it was certainly not converted to non-forest. This is all complex EarlySterile forest. It is vigorously regenerating, and this is wonderful carbon-rich wildlife habitat. And the same thing is true in giant sequoia forest ecosystems. These are hundreds of giant sequoia saplings, hundreds per acre, in a high-intensity fire patch. This is the Nelver Grove. I took this picture just a few years post-fire, and the sequoia regeneration is far and away the most abundant and growing the fastest and tallest in the higher intensity fire patches. I took this picture here. This is also Nelver Grove. I took this picture just a couple of weeks ago. I don't have anyone standing there, but for scale, the taller ones are about 8 feet tall. That's just 5 years post-fire. These are sequoia regeneration. And this is giant sequoia regeneration at 2 years post-fire in the Castle Fire that burned in the southern Sierra Nevada in 2020. This is typical. That's we've got hundreds and hundreds per acre of giant sequoia seedlings coming in. So this is what we're seeing in these areas. We're not seeing type conversion to non-forest. We're seeing vigorous, abundant, natural conifer regeneration, including in the sequoia groves. In fact, we have far more conifers, far more giant sequoias per acre after these fires than we did before. And these are sequoia groves that had basically had almost no regeneration for over a century because of fire suppression. Now, if we did a large-scale study, a field-based study over multiple years in the Rimfire, and we found that once you have appropriately sized field plots, you have to have field plots that are of a significant size, especially 10, 20 meters in diameter. I'm sorry, in radius. 20-meter radius is really what you want to be able to understand whether you have conifer regeneration in a given area. And when you have that, what you find is that the vast majority of these large, high-intensity fire patches, even deep in the interior, have conifer regeneration, almost very close to 100%. And the bottom line, I'll show a few more slides and then we'll wrap it up and go to Q&A. But I just want to show you the areas that really are being converted to non-forest and what's causing that. It's not the fires, it's not the beetles, it's logging. And in particular, it's post-fire logging under the guise of restoration and reforestation. This is Dr. James Hanson and I, once again, we're standing just a couple hundred meters away from the picture I showed you earlier of the two of us. And this area, unlike the other area, was post-fire logged. But this was post-fire logged several years before this picture was taken, and it was planted. And what you see is basically, largely bare ground, some grasses, mostly invasive grasses. It's cheatgrass mostly that's brought in by the logging machinery, stumps, some slash debris, and just a tiny number of conifer seedlings that survived after they planted. Most of them died because of all the damage done by the post-fire logging, a lot of soil damage. This area, very similar. This is an area that's right next to the photo I showed you earlier that was deep in the interior of that largest high-intensity fire patch. That was all natural regeneration. It had not been logged or planted. This is right next door. It had been post-fire logged and planted years earlier. And you can see there are some conifers that they planted that are surviving, not much. Mostly it's cheatgrass, an invasive weed that's highly combustible, brought in by the logging machinery. And basically, this has been type converted to non-forest by the logging. And another example from the Rimfire. So we see this again and again. You can see that some of the trees they planted survived and are growing, stunted, but they're growing. But most of what they logged and planted is just type converted to non-forest. And this is more. This is actually in the Rimfire, subsidized by taxpayer dollars. This is what we call clear cuts for kilowatts. This clear cutting was done for biomass, to burn the trees for energy, which produces enormous amounts of greenhouse gases into the atmosphere. And this area was naturally regenerating, but all of that got cut and hauled down to the biomass facilities, not just the snags, but also the naturally regenerating forest, which was about 8 feet tall at the time before they cut this. So bottom line is that the type conversion that we're seeing out there, the forest loss, it's coming from logging. It's not coming from natural disturbances. And the claims by Forest Service scientists in these papers like Steele et al. 2022 about forest loss from natural disturbance are wildly inaccurate and exaggerated. You can get a lot more information again in my book, Smokescreen. And I'm going to stop sharing here, and I would love to hear any questions that folks might have.
Awesome. Thank you so much, guys. That was a wonderful presentation. And we have got some really, really great questions submitted into the chat. So again, just for clarification for everybody, if you would like to submit a question, please use the Q&A board, and anything that we don't get to cover in these last 20 minutes, we will submit in our follow-up materials in a written format. This first one is from Katie Billadu. She was asking, did the authors justify why they used a 25% threshold canopy cover for classifying a forest instead of the 10% this others use?
Yeah, as Dr. Hanson mentioned earlier, they actually reference this. They cite a Forest Service General Technical Report. And this is really interesting. So they cite it when they say 25% is the difference between forest and non-forest. They say 10 to 25% they could call savanna or woodland, but they don't specifically analyze that. So they use that 25% and say anything less than 25%, we're just going to call non-forest. And they cite this general technical report. What's really fascinating is that there's another paper from a few years ago by some other Forest Service scientists who cite the exact same technical report. And they say that report says 10% is the threshold between forest and non-forest. So you have two different papers citing the exact same reference, and they're coming up with two totally different numbers. That paper doesn't really talk about the difference between forest and non-forest, that technical report. It really talks about tree-dominated versus not tree-dominated habitats. But there are a lot of other papers. The literature is full of references about what's the difference between a forest and a non-forest. It's about 10%. What's also really interesting is that some of the authors in Steele et al., so at least one of the authors has co-authored a different paper back in, I think it was like 2015 maybe, where they were talking about historical forest, and they were saying, historical forest, and there's a lot of debate about this, that Dr. Hanson has shown that a lot of their assumptions and data were incorrect about this, but they were saying that historical forest in the Southern Sierra Nevada had on average like 12% canopy cover. So they were talking about forest specifically, historically having much less than 25% canopy cover. And they were saying that was good. And that's what we need to try to get back to. But then the same authors are now saying anything less than 25% canopy cover is not forest. So it's just an arbitrary thing, perhaps to suit, I don't really know. I don't know exactly why they did this, but regardless, as I was sort of showing you, the canopy cover data are highly suspect. There's something seriously, fundamentally flawed with the data. I have looked across their study area. It is not making any sense to me. We are trying to quantify basically the percent the error on their data set, and we've come up with a method to do that. But yeah, there's something really bizarre happening here, and that it got published and went through peer review and then was picked up by a bunch of major news organizations is just beyond me.
That actually blends pretty well to the next question. Brian was asking, how could Steele et al. 2009 get it so wrong, and how did they get published without peer review finding these blatant errors? We may not have a specific answer for that, but that's definitely
I have one.
We'd all love to know. Go ahead, Chad.
Yeah, it's a really good question. And sorry if I'm being a little flip, but I think a little irreverence is called for when we have inaccuracies at this scale. So there is a problem in the scientific community right now. There's a problem, and we need to talk about it, because you have several dozen scientists who are funded by entities that are involved financially in commercial logging: the U.S. Forest Service, CAL FIRE, in some cases just logging corporations like Sierra Pacific Industries. These scientists, some of them work for universities, but they're funded by logging companies, or they're funded by the Forest Service, which is involved financially in commercial logging. And they function as a group when they publish papers. So not only do they publish together, but when they submit papers, there is nothing in the peer review process at these journals that prevents other members of this same group of logging industry funded scientists from reviewing papers published by the same group. And so you have US Forest Service funded scientists reviewing papers from other US Forest Service funded scientists. And in many cases, the editor and the associate editor are also funded by the US Forest Service. So imagine if, my organization, the John Muir Project, if we had, if I submitted a paper and another John Muir Project scientist was reviewing my paper, there would be howls of protest. But this happens every day with the Forest Service, and no one says boo about it. It's a problem. And so that's why really just obviously profoundly flawed, profoundly inaccurate research is getting published. Now, the other thing I'll say, and then Bryant may have a thought on this too, and then I want to hear other questions also, but this must be said, is that these researchers did not just produce an inaccurate study. They produced a highly hyperbolic and attention-grabbing result that they knew would grab headlines. And then they, in the paper itself and in their quotes in the press, called for rollbacks of environmental laws and more funding from Congress to facilitate more logging, to subsidize more logging. And so these are scientists who are funded by logging interests, pushing policies that will financially benefit those same logging interests, and doing it through the context of a very, very, well, forgive the term inflammatory and attention-grabbing and highly inaccurate body of research. This paper, unfortunately, is not an exception. There are a number of examples like this. It's just the most recent kind of alarming example.
I will just mention, not really, but I will just mention that some of these authors have co-authored several papers over the last few years that have been funded not just by the Forest Service, but also by Sierra Pacific Industries, which is, I think, the largest private commercial timber operator in California. And those papers have also had co-authors that work for Sierra Pacific Industries. And it's just really bizarre when I see that. I see quite literally the timber industry funding these papers and having their own people on these papers. And those aren't really questioned. And then, the second Dr. Hanson, publishes a paper, they lose their mind, and it's very, very frustrating. So yeah, I could talk a lot more about that, but I want to go into other questions.
Yes, let's, I have some pretty good ones. There's a couple I'm going to lump together because they're all on the similar vein, and it's regarding forest designations. So why does this designation of forest versus non-forest matter? Are we talking about legal categories that allow logging? And then a more specific question is, why is shrub habitat not considered forest?
I think so. It kind of goes back to what Dr. Hanson was just saying, is that this was extremely hyperbolic, inflammatory. I mean, it's like we sometimes call it pyroganda. It was attention grabbing, and it was really about this designation between forest and non-forest. It really it was about producing those headlines that say we lost 30% of conifer forest in the southern Sierra Nevada over the last decade. I do think that alone has already caused elected officials to, they talk about these news paper articles, and then the study itself, and they use that as reason and justification for why we need to be ramping up, logging across national forest that is under the guise of, fire mitigation, right? This is all very purposeful in bringing attention to this issue, so that we, to try to increase the use of logging in these forests, as an approach to wildfire mitigation. And of course, there are a lot of issues with that. I think legally, when areas get classified as non-forest after a fire, it does make it probably. I don't know if there are anything legally, but the Forest Service will certainly target high severity areas, high intensity fire patches for salvage logging. And what they'll say, they're going to do a bunch of replanting. They'll often just call those like fire restoration projects. It certainly makes it easier for them to justify what they're doing, even despite what we're finding, which is that, you have a lot of natural conifer regeneration in these areas. And it's kind of about the shrub. Why is shrub habitat not considered forest? I mean, you're kind of getting into a more complicated question, which is like, what's the difference between a shrub and a tree? There's actually a lot of debate about that. Like, how do you actually distinguish between the two? And I don't think we need to get into that too much. It is important to try to have some definition of what do we consider forest versus woodland versus shrubland. That is important. I think what's maybe a little more important is looking at the different types of ecosystems. So, I mean, like, a conifer, a forest in California is going to be quite different than a forest in some other part of the world on the eastern seaboard. I mean, it might be different in terms of its species composition, natural fire regime, other disturbance dynamics. I think that might be more important in the end, but it is important to have some sort of definition. I just think that Steele et al. Got it wrong with choosing that 25% canopy cover as one of their key criteria. I don't think it made any sense in this case.
Yeah. Anything to add, Chad?
Yeah, I'll just add two quick things. I agree with all that. Also say that from a legal standpoint, it does matter, as Brian kind of alluded to in terms of logging. If they can classify areas after a fire as non-forest, then the protections, weak as they are in the forest plans, are typically exempted, and they can go in and clear cut those areas, or largely clear cut them after the fire. And so it does have implications on the ground. But the other thing I would say is that it's really part of a political narrative. And I say that very purposefully. This is a political narrative that, and the whole purpose of this is to basically drive a conversation that's predicated on fear and shock value. Because if you get people scared enough, then they oftentimes will support policies that are regressive before the smoke clears and they realize that they've been hacked and they've been misled. And that's what's happening right now. So they're using this kind of shock and enlisting the media to drive this narrative that this massive loss of forest, and therefore we must roll back the environmental laws and log the hell out of the remaining forests in order to save them from fire. And there's all kinds of problems with that, of course. But that's really what we're seeing right now. And unfortunately, the media stories, including the LA Times story that Bryant mentioned, they didn't even reach out to any independent scientists. They only quoted the scientists who were funded by logging interests, which is a major problem from just a journalistic standpoint.
Absolutely. And kind of touching back on that question, it does give itself the opportunity that we could have a whole webinar just to discuss that last question about forest designations and how they differ and what the implications of that are. So maybe stay tuned, guys, for a new announcement on that. We have a pretty great question here, but I did want to do a time check with our panelists just to make sure we are at the top of the hour. I feel like we could maybe squeeze in 1 to 2 more questions. We have perfect. Okay, we have a bunch that are still in the chat that have not been answered. I want to reiterate to all our participants, with your registration, all the questions that we don't get to in this verbal conversation will be answered in a written format and will be distributed out as well. So if you did not get your question answered, because there's a lot of really, really good ones, just know that the answers will be coming to you from both Dr. Hanson and Mr. Baker right afterwards. So I'm going to close it out with, I think, this question. Considering the serious methodological flaws used by the U.S. Forest Service scientists in their research that you outlined, how can we increase accountability to ensure that research and findings are accurate and that the use of sound methodology and then are correctly used by the media and policymakers? How do we make this better?
Yeah, I think that's a great question. I mean, I think there's a few things. First of all, we need to reform the peer review process when it comes to forest and fire research. We need to have a candid conversation in the scientific community and amongst scientific journals about the fact that there's a group of scientists who are funded by logging interests, and there's a series of misleading and inaccurate studies, all of which promote logging. And so we have to talk about that. Second, I think we just need to educate. All of us need to be involved, not just those of us doing the research. We all need to be involved educating the media and policymakers about these inaccuracies and in many cases, the financial motives driving it. I will say briefly, just to the last question, I just have to say this, especially since Bryant and I are doing this together. To the question about shrubs, after a high intensity fire patch, if it's dominated by shrubs, it is absolutely still forest. Particularly if the conifers are regenerating, and that process takes time. Sometimes it'll be 15 years later, the conifers are dense enough and tall enough and the shrubs start dying back. That's just natural succession. And so the presence of shrubs, even dense shrub cover after a high intensity fire patch, that doesn't that doesn't declassify it as forest. In fact, that's a classic natural succession stage in the succession of that complex early seral forest to mature forest again.
And we see it all the time. In the Southern Sierra, I mean, I could show you hundreds of photos and videos from the Rimfire area where you would go out in an area that had been, dominated by very large conifers, and then they died in the fire. And you have this wonderful, amazing, sort of diverse shrub development that has happened for several years after the fire. And you might look at that and say, oh, this is converted to shrubland or something, right? And there couldn't possibly be any conifers there. Dr. Hanson and I have quite literally bushwhacked into those areas and crawled on our hands and knees, and you will find conifers usually under the shrub canopies, in places. I mean, it's amazing. And I don't think I first believed it. I was looking at an area, one of my first field trips with Dr. Hanson. He was like, I'm telling you, if we go in there, it's like, it was mostly like ceanothus. It was deer brush, which is actually very important post-fire. It's a nitrogen fixer. It's putting nitrogen back in the soil. It's actually prepping that area for conifers to be able to thrive. But I didn't really think that we would find any conifer seedlings or saplings. And at like 7 a.m. one morning, we just started crawling through the shrubs, and I could not believe the number of incense cedars and white fir and ponderosa pine that we were finding. It was just incredible. I actually I've been doing it ever since. Going back to these places and trying to bushwhack where I can. So yeah. Anyway. I had one thing I wanted to add, but I can't remember what it was. But
and if everyone's cool, we could take one more question maybe before we go.
Oh, perfect. Awesome. All right, let me quick scope through. Find a really good one. Okay, here's one that's, I think, just a good question to answer and give good resources for the people who are here, and then also for those who will watch this later. This is a question kind of referring to, how do we cite our sources? Which journals then have real peer review and non-industry funded studies? And what would you suggest people go to, and how to vet those sources?
Yeah, that's a good question. I think I talk about this a lot in my book, Smokescreen, and certain journals come up as kind of bad actors these days. So some of the journals that are kind of frequent flyers and these sorts of problems that we see with manuscripts are Frontiers in Ecology and the Environment and Ecological Applications. Steele et al. Was published in Ecological Applications. Those two are two of the biggest problems, and there's a smattering of other journals where it's a problem here and there. Most of these journals, I don't think that they mean to do harm or wrong. I think that they just don't realize the problem and the conflicts, the financial and political conflicts that are out there among this group of scientists that are funded by the Forest Service, by Sierra Pacific Industries. And they're just kind of blindsided by it. And so they get a paper that's submitted by these scientists, and they send it out for peer review, and they're picking other scientists that are funded by the same logging associated entities, and they don't quite realize it. And so I think we just need to daylight it more. And a lot of these journals, I think, will institute reforms. But a couple of them have been repeat offenders in fairly egregious ways. And again, Ecological Applications and Frontiers in Ecology and the Environment come to mind as two of the worst, in my opinion.
I have two things to add. One related to this question. The other is what I remembered I wanted to say in the last one. So first, related to this question, I don't know how to fix this in the peer review process. I'm not sure that there's a way. But as someone who's been doing GIS work for the last decade, I looked at these data sets that Steele et al. Made available, and immediately found these issues. Like, no problem. Like, very quickly, very simply. It was so obvious, and I just kept thinking, like, somebody who has any GIS experience, is used to looking at these data and looking at aerial imagery or satellite imagery. They would have spotted these during development process of this paper. And they would have done, I mean, we do this all the time. We spot check, like we go in and make sure like what we're, the data sets we're creating, that they make sense based on what we're seeing from, more qualitative data like aerial imagery or satellite imagery. And I'm just still sort of baffled as to what happened here, because I do think a lot of it is maybe, I think there's some willful aspect to it, but also I think it's just like you prep these massive data sets, you don't really do much spot checking, and then it produces a result that looks good to you, and so you don't think much about it afterward. And I just we have to fix that. There has to be some issue, and a lot of like peer reviewers, they don't have any GIS. They may not have any GIS knowledge, so they don't know to even look at those data and look for those issues. And that may be a little bit more beyond the peer review process, which peer review is really about making sure that the concepts make sense, that the methodology generally makes sense. But it almost is like we need a way to make sure that the data makes sense. That's the other aspect. Now, what I wanted to say in the last question was just something about how we view forest, just in general, how we think of forests. They are spatially and temporally dynamic. We often think of them as this static thing that's not supposed to change, but they do change. They change frequently. And a lot of times it's like small changes over time, but sometimes it's like this really big change that happens all at once. And then that sets off a series of other changes that will happen over many years. And so this is all part of natural forest succession, as Dr. Hanson was talking about, but it's going to require, like, if people are going to understand, that a forest isn't lost because it's burned, they need to understand that forests are dynamic and that they go through these changes, and it creates this amazing biodiversity, and all of these things happen. Maybe you won't see mature conifer trees for many years after a high intensity fire. That's okay. There are these other things that are happening in that time frame, like all those shrubs. Like I said, a lot of those are nitrogen fixers. They're putting nitrogen back in the soil. They're also they're all flowering shrubs. They are providing incredible habitat for pollinators. There have been tons of studies that have found that high severity fire in forest actually it creates better conditions for native bee diversity and other pollinators, which then those native pollinators attract all these different types of birds. So you have a lot of bird species that you only really find in high severity fire patches in these forests. We're just not thinking about forests in the right way sometimes. And this paper, I feel like, reinforces those issues, even though they have this whole section about how we need to adopt managed dynamics and all, they have this like language that maybe sounds good, but the very concept of what they were doing, which was like, X percentage of forest over this time period transition to non-forest, it was already fundamentally problematic from the get-go. So.
Awesome. Thank you guys so much. With that, I think we're going to wrap up our webinar for today. Just to reiterate one final time, if your question was not answered during our discussion, it will be sent to you in a written format with our follow-up materials as part of the perks for registering for the webinar today, and you can use that information as you will. We try to get our webinars up on our YouTube channel within a 2 to 5 day turnaround. So I'm hoping that we will have this up by the end of the week. And that's permitted, giving Dr. Hanson and Mr. Bryant some time to work on those questions that you guys have submitted that we didn't get a chance to. But thank you so much, everyone, for coming. I super appreciate having Dr. Hanson and Mr. Bryant share their expertise with us. And we hope to catch you guys on the next webinar for understanding the science. Thank you guys so much, and have a wonderful rest of the day. All righty.